So this is going to be a revision video on topic 8b, accuracy and estimates. Now we're going to begin with some definitions of what accuracy and estimates are. And the first one I want to start with is accuracy. When we talk about accuracy, it means that accuracy is a measure of how close a value is to the real value. And so what that means is the closer the value I have, or the closer the value is to the actual real value, the more accurate it is. That also means, though, that the further away a value is from the real value, it means then that that value is a lot less accurate. Now, on this slide, I have a little question which will allow yourself to test your knowledge on this topic. You can see there are three balances, or three scales, but often we refer to them as balances. Balance X, balance Y, and balance Z. I want you to look at those three. And I then want you to read the two questions which are on the right-hand corner of the screen. And question 1A says, the real mass of a jar containing sunflower seeds is 1.853624 kilograms. It asks you which balance in diagram A shows a value closest to this figure. And then question B says, which is the least accurate balance, and then asks you to explain your answer. I want you to pause the video at this slide, have a go at answering these questions, and then when you flick on to the next slide, I will show you the answers. Pause the video now. The answers then, 1A, it would say, or your answer should be, that balance Z shows the answer closest to the real value, and so therefore that is the balance that is the most accurate. The balance that was least accurate was balance X, and it was least accurate because it gives a figure which is actually furthest away from the true value. Now, moving away from accuracy, we want to look at the difference between accuracy and estimates. Now, when we talk about an estimate is an approximate value, so it's not accurate. It's often approximate because we actually do not need an accurate value. And one of the ways that we can actually calculate estimates is using samples. Now, this would be an example of when you could use sampling. So imagine you go to a fun fair, you see this jar as a competition, and you're asked to estimate how many sweets are in the jar. Now, you have two options. First option, guess. Make a wild guess, might be hundreds, some people might even go into thousands, but you would be taking a wild guess at how many sweets are in that jar. You could, though, make a calculated estimate, and this is how you would do that. You would start off and you would measure the height of the jar. Now, I measure the height of the jar, and the height is 30 centimeters. I then count how many sweets are in the top 1 centimeter of the jar. So I only measure the top 1 centimeter, and I measure 46 sweets in that top 1 centimeter. What we can then do is we can use those two figures to calculate how many sweets in total are in the jar. And this is how you would do it. I would say the sample size was from the first 1 centimeter. Now, 30 centimeters is 30 times bigger than 1 centimeter. If I counted that there were 46 sweets in the top 1 centimeter, then I could assume that there are roughly 46 sweets in every centimeter. And so therefore what we could do is we could estimate that 46 sweets, we would multiply it by 30 because the jar was 30 times bigger than the sample I took. And therefore we would get this many sweets in total in the jar. Now, that's not the only way we can use sampling. One of the other ways in which we use sampling is we often use it to determine the size of populations without actually going to have to count all the organisms in that population. Now, what I mean by that is imagine your teacher sends you out onto the field. The field would be the complete area, or it would be the habitat, and I want to know the population of daisies on the field. So I want to know how many daisies are there in total on the field. You could go out and count them all. Now, that would take you a very long time, but you could also estimate the number using sampling. And again, this is a way in which we could do it. And I'm going to talk through the steps of which we could use to sample these daisies. So as you can see here, this lady is using a sampling technique. We call this technique quadrating because she's using this square piece of equipment called a quadrat. And so what you would do is you would start off and you would measure the size of the total area. So you would go out with a tape measure or a trundle wheel and you would measure the total area of the field. You then would randomly, and that's really important, randomly select where to place the quadrat, but we wouldn't just throw it. We would randomly select the area where we would place it. We would then count the number of daisies in that quadrat, and we often don't, if a daisy is half in and half out, we only count it if more or half or more is inside the quadrat. Then what we would do is we would calculate the total number of daisies in the field using the following equation. So we would take the number in our sample, so that would be the number inside my quadrat. We would then multiply it by the area of the habitat, which remember I worked out by measuring the field, divide it by the area of my sample. So I would measure the area of the field, I would measure the area of my quadrat, and I would divide the area of the field by the area of the quadrat, and then multiply that by the number in my quadrat. And that would give me a rough or an estimate of the population size in the field. Now, this is one of the examples, or this is one of the examples that they could give you in a test. So it says here, use the sample from the diagram to estimate how many plants would be found in a field of 500 meters squared. So we would use our equation again. This was our equation, and you would work out the population size. So if you look there, our population size, to work out, we would count how many flowers or how many plants are inside the quadrat. If you count that, we can count that there are 10. So that's what I would start off. 10 are in my sample. I then multiply that by the area of my habitat, and the question tells you that the area of the habitat is 500. I divide that by the area of the sample, and I can see the area of my sample is 1 meter by 1 meter. And once I do that equation, that then leads you to 10 multiplied by 500, which means there would be an estimate. Remember, this is not necessarily an accurate answer, but it is an estimate of 500 plants in the whole population.